Hello everyone and welcome to the second exercise of the Numpy exercise in session 1F of HSMA. That was the second Python programming session. So we're working with Numpy again. I'm going to kick off by importing Numpy as NP. And remember, if we want to avoid it in trying to overwrite what we want as our import, we just press a space after we've typed in NP and we will be able to get away from the auto select or the autocomplete. Now, what have we been asked to do in this particular exercise? Well, we've been told that training provider has 10 centres, each with 1,000 students. So we want to randomly generate some scores for each student. These will be a NumPy array and the score will be between 0 and 1. So that's actually representing a percentage. So for example, if we've got a score of 0.32, we're going to interpret that as 32% achieved on the assessment, 0.99, 99%. A score of 1 exactly would be 100% and 0 would be 0%. We're then going to calculate the mean score achieved by students at each centre. So for a given centre, if you average the scores of all of the students in that particular centre, what would they get? Once we've calculated it, we want to convert the means into percentages. So actually we're going to turn them into values between 0 and 100 and store this as a NumPy array. And then we are going to round these to 2 decimal places, which we're going to keep in the same array as previously. Finally, we're going to print out the output. Now, we haven't been told what some of the functions we need to use in this case are. We have been told to resort to our Googling skills or to the NumPy documentation. So I have done that. I've gone away and I have searched for NumPy create array between 0 and 1 random numbers. And there's a couple of suggestions popping up here. There's Google's given us a nice suggestion here from a website called Programmers. And actually looking at some of these, random rand int generates a one-dimensional array of 5 random integers between 0 and 1. That's what this code would do. That's not quite what we're looking for. Random rand5 generating a one-dimensional array of 5 random numbers between 0 and 1. Now that is sounding more promising. So I'm going to carry on looking into random rand5, and if I scroll down a little bit, I can see that I've got the NumPy documentation here at numpy.org, and it is popping up with this particular suggestion again, NumPy random rand. So let's click into this and see what it tells us. And actually the first thing it's telling us is this is actually for an old release of NumPy. What we probably want to do is go into the this page in the documentation of the latest stable release. Not the end of the world. This is probably not a function that's changed all that much over time, but good to be using the most up-to-date documentation if we are using a more up-to-date version of NumPy. And actually you can see at the top right here, it's similar for quite a lot of packages, things like pandas, etc., where they're quite big and well-known packages. You might be able to click on a little drop-down and look at the different versions of NumPy that you might be interested in seeing the documentation for. So, what have we been told? So, NumPy random rand will allow us to create an array of the given shape and populate it with random samples from a uniform distribution over 0 up to 1. So actually this is not going to go all the way up to 1. Potentially this little bracket here means that so 0 is included, that's why we've got the square bracket at this end. 1 is not actually included. For the purposes of this exercise, I know from the solution we've been given that the intention was to use this function, so it's actually just a little bit, it's not quite what what the questions asked for. There are other functions out there, but for today we're just going to use NumPy random rand. So what kind of examples are we being given here? So NumPy random rand, so this looks like we will create a 2D array if we pass in 2 parameters. So that's given us, for example, we could think of that as three different schools, or 3 different, was it schools that we were talking about in this particular exercise? Centres, training provided with centres. So actually each one of those rows we might think of as being our centres, and the columns we might be thinking of that's student 1, so that's student 1 at the second centre, that's student 1 at the third centre, and student 2 at the first centre, student 2 at the second centre, and so on. So actually it looks like we could copy in this, and we could say that actually what I want is, I want 10 centres and I want 1,000 students at each centre. So remember, looking back, we know that because here we got effectively 3 centres with 2 students each. So we want 10 centres with 1,000 students each. So that is our first array, and I'm going to want to save that something. So we're going to call that students. Now the next thing I'm going to do is calculate, well, let's first just have a quick look at that to make sure it looks roughly like what we're expecting. And we can't actually see the full array for each case because actually it gets a little bit big, and Numpy doesn't want to display all of that. It's an awful lot of data to show up on the screen, but roughly we can see that we have got 1, 2, 3, and then these dots show that actually there's some stuff in the middle here that we're not being shown, 4, 5, 6. So actually, hopefully there are some additional arrays here, and these dots in between again are saying, well, you've got 1, 2, 3, so many, so on, up for student scores. But you can see that we've got these decimal points here. We've got numbers that do look like they are falling reliably between 0 and 1. Let's just play around with this a little bit more. So what happens if we say we want to find the 0th element in this array? So actually then we are getting all of the scores from a single centre, effectively. So if I was to print the length of this array, then we would see that there are 1,000 scores in there. If I was to do this again with 1, then again that's actually centre 2 in the way we might think about it, but it's because Python starts counting from 0, and as does Numpy, we go 0, 1, 2, etc. So that looks like it's all working. Now the other thing we might want to do is say that we want all of this. Let's not worry about that for now. But what we want to see is actually how can we look at the dimensions of our student scores. I think we actually can. So if I were to print student scores.onDim, so this is an attribute of the student scores Numpy array, which is why we don't have any brackets after it. I could also print the shape of the array, again another attribute, so we're seeing again that we've got this 10, 1,000 shape, which we would be expecting because that's what we asked for. But that is just a good indicator that we've got what we were looking for in our array. So what shall we do next? Well, we've been asked to calculate the mean score per centre. Now, I think what's important to remember here is that the way that we know that we can do np.mean student scores, but then we need to think about what happens when we use the axis parameter. Now, one axis 0 will calculate the mean score for every for student. So effectively it will look at going, okay, for student 0 across every single one of these arrays, then what did student 0 across these 10 centres, these 10 testing centres get? We don't want that. We want the mean per centre. But let's just try it with this axis of equals 0 first and see what happens. Now this still looks a bit long, doesn't it? And I think if we were to print the length of this, we would see 1,000, and that's exactly what we're getting. So we have 1,000 items in our array, and that is because we've got the average across student 0, the average across student 1, the average across student 2, across the centres. If we were to put axis 1 instead, then you can see we've only got 10 items in our array. We've got the average for students in Centre 1, the average for students in Centre 2, Centre 3, and so on and so forth, which is what we were looking for. I think the other thing that's quite interesting to note is that the averages seem to be centering themselves somewhere roughly around 0.5, which is what we would expect. We have randomly sampled numbers between 0 and 1 at a very large scale, and just by random chance we would expect these to have a mean of roughly 0.5. So we can now save this. We can save this array. Let's call it mean per centre. And the next thing I'm going to do is I'm going to times this by 100. So we've been told to make this a new array. So actually all I have to do here is nice and simple. Mean per centre, let's call it mean per centre perk, so we can recognise that this is the one with the percentages in. Mean per centre times 100. And let's just print that so we can see what it looks like. And you can see now we've updated to something like 49.89, 48.72, 49.69. Now, the other thing to note is when I reran this, you might recognise that these weren't exactly the same values as before. Now, that is because we are using random number generation. So each time I rerun this code, then it is going to pull out a new set of random numbers, and they might be slightly different to the previous set of random numbers that I generated. There are ways to control this within Python. If you need things to actually have some reproducibility, some consistency between runs, then there are ways we'll cover later in the course to do that, but for now that doesn't matter too much. So next thing I'm going to do is I'm going to say that I want to round this. Now, again, we had our we've been told we don't know what this function is. So here's my search that I did earlier. I searched for round array numpy, and I've got two things have popped up from the numpy manual. It's told me that the numpy.around function will round an array to the given number of decimals, which sounds like what we want to do. It's also said that around is an alias of round. That just means that round and around, or array round as you might think of it, will do exactly the same thing. So what I'm going to do there is I am going to round this array, and we've been told if I scroll back up a little bit so we can actually see the question, we've been asked to overwrite the same array of percentages. So that just means I'm going to call mean per centre perk equals mean per centre. No, that's not what I want to do. I need to do numpy dot round, and I'm going to say please round the mean centre percentages, and actually I need to be able to pass in the number of decimal places. We've been told we want to round it to 2 decimal places. So if I go back to this and go into, so I'm in my Google search, I've now clicked into the NumPy around documentation, and it's told me that the first argument is going to be an array of some sort, and the second argument is going to be the number of decimals that we are interested in. If I was to click into the round function, actually you can see that we've got a little bit more detail here, so it makes it a little bit clearer that A should be an array like some sort of array effectively, and that actually the second argument is the number of decimal places to round to. The default is 0, so what we want is to say please round this to 2 decimal places, and then I'm going to run this again, and you can see this time we have got 50.66, 50.85. We've also got 51 with just a dot. We've got 51.96, 49.6. Now all that is, the reason it hasn't consistently put 2 decimal places is because it doesn't, if it rounds to 49.60, then Python just goes, well, that 0 is effectively meaningless right now, then we don't really want to print it. There are a couple of ways, if we were sort of pretty printing this for, well, let's actually have a go. So let's do some sort of pretty printing for, assuming we were going to be doing this as an output to a stakeholder. I'm going to just use a little list comprehension here. Am I going to use list comprehension? Yeah, let's use a list comprehension. I'm going to do a format string. Actually, no, I'm going to say for number in this array. So for every number in the array, please go through and can you format it as a number to two decimal places. Now let's see what happens when we do this. I'm just going to get rid of this print statement. Actually, no, we can keep both of them. Let's print and then we can compare. Doesn't like that. Format specifier missing precision. Oh, and that's because I've messed this up. That should be dot to F. So saying please put it to two decimal places and format it as a number. If I run this again, you can see now that actually when we have been when we've rounded it, we obviously this time we haven't got exactly the same situation because we have not been. Why is that not rounding anymore? Now that's a little bit strange. Oh, why is that not rounding? Because I've got a typo. So I've got, that should be PERC. That should also be PERC. I just can't spell today. So let's try that again. And you can see, yep, now we're getting this as our array. And you can see here we had 51. And here in our pretty printed array, where we said please make sure that you are formatting this number with two decimal places to display regardless of whether this zero matters, then you can see that we've got 51. Now, another cheeky little tip for you, if I were to copy this line and actually say, let's go back to our mean per center, and remember this, if I just print mean per center, I'm just going to comment out these lines a second so you can just focus on this one. Now, I printed mean per center and you can see it's got lots of decimal points and each one is starting with a 0. If I were to copy this list comprehension and say for number in mean per center, so actually that was the one that I was about to create, so for number in mean per center, whereas previously we were pointing at this array, the one where we've rounded already, this time I'm going to point towards this array, the one where we have not rounded already. And I'm going to say please round it to two decimal points but also make it a percentage. So I'm just going to change this F in my format string to a percentage. And what we will now get is a nicely formatted string again with two decimal places and a percent sign without having to do all this multiplying by 100 step. It's all done inside this formatting string. And I think that's everything we needed to do for this exercise. So yeah, that's our time with NumPy done for now.